Section 7.2 is on multiplying and dividing rational expressions. And this pretty much comes down to our ideas for multiplying and dividing fractions. We notice that a divided by b times c divided by d has to be the same thing as ac divided by bd as long as b and d aren't 0. So what does that mean for a rational expression? If we had x divided by x plus 2 times the quantity x squared minus 4 divided by x squared, we notice that we could write this as x squared minus 4 divided by x plus 2 x squared, and then we could factor everything. We get x minus 2 x plus 2 divided by x plus 2 x times x, and so the x plus 2's go away, the x's go away, 1x goes away, and so we're left with x minus 2 divided by x. We notice, though, we are always going to get that same structure, and so we can actually simplify before actually doing the multiplication. So what we could have done instead is looked at it as x divided by x plus 2 times x minus 2 times the quantity x plus 2, all divided by x times x. And so before doing anything with multiplication, we could have just gotten rid of the x plus 2's, gotten rid of an x, and we get x minus 2 all divided by x with much less writing. That said, if you want to write it the long way, there's nothing wrong with that. Both methods are perfectly valid. So if we looked at x squared minus 3x minus 4 divided by x plus 2 times x divided by x squared minus 1, we notice that we have to factor a bunch of stuff. We have to factor everything, and then we check for common factors. So we notice that x squared minus 3x minus 4 is going to be x minus 4 times the quantity x plus 1, all divided by x plus 2, times x divided by x squared minus 1, factors is x minus 1, x plus 1, and so we see the x plus 1's go away. X plus 1 divided by x plus 1 is going to be 1, and so we notice that we're left with x minus 4 times x divided by the quantity x plus 2 times the quantity x minus 1. And at that point, what we notice is we can leave it factored like that. We should specify as long as x isn't negative 1. I'm not going to take points off for that unless the question specifically asks for it, but you should be aware of those domain restrictions. Just like up here, we should have specified x can't be negative 2. But then what we also notice is that while this is correct, sometimes we want to leave it factored, other times we want to multiply it out. We could also write it as x squared minus 4x divided by x squared plus x minus 2, as long as x isn't negative 1. And so the question of whether to leave it factored or to multiply it out really depends on what you're doing. Sometimes we prefer it factored out, other times we prefer having it multiplied out. So it basically amounts to, are you going to be doing something more with it, working with it more, or using it as a formula? Factored is usually more adaptable to other uses. Multiplied out is usually more effective to use as a formula. Dividing rational expressions winds up being very similar. We recall that if we have a divided by b divided by the quantity c divided by d, that's the same thing as a divided by b times d divided by c, which will be AD divided by BC as long as BC and D are in 0. So all three of those can't be 0 now. And so if we had x divided by x plus 2 divided by x squared divided by x squared plus x minus 2, we notice that our first step is to rewrite it as multiplication by the reciprocal. So we first say equals x divided by x plus 2 times x squared plus x minus 2, all divided by x squared. And what we notice is that we can do the multiplication by the reciprocal and then do the factorization. But you notice we could also have done the factorization at the same time as we're multiplying by the reciprocal. So we notice that we could have technically skipped this step. That said, it's just a question of personal preference. You can keep that multiplication by the reciprocal step, then factor, or you can factor right away when you multiply by the reciprocal. Just remember, we do have to multiply by that reciprocal. So now, this looks kind of familiar. We notice that the x plus 2's go away, one of the x's goes away. So you notice sometimes, especially when it's an x and x squared, you just get rid of the squared, leaves behind an x. And so we get x minus 1 divided by x, as long as x isn't negative 2. So I'm generally going to include that restriction. As I said, I'm not likely to take points off for it unless it's part of the stated explicitly as part of the question. So if we look at something a little more interesting, if we wanted to have something like x squared minus 3x minus 4 divided by x squared minus 4 divided by x squared minus 1 divided by x squared plus 5x, make it x squared plus 6x plus 8. We notice, again, we're looking at that as x minus 4 times the quantity x plus 1 divided by the quantity x minus 2, x plus 2, then multiplying that by x plus 4, x plus 2. We know x squared plus 6x plus 8 is the quantity x plus 4 times the quantity x plus 2. And because it's division, we move it to the numerator. And then they'll be divided by x squared minus 1 factors as x minus 1, x plus 1. And so we notice that the x plus 2's go away, the x plus 1's go away, and we're left with the quantity x minus 4 times the quantity x plus 4, all divided by the quantity x minus 2 times the quantity x minus 1, as long as x isn't. And now we have to be a little bit careful because we're restricting x can't be negative 2, it can't be negative 1, but we also have to pay attention to that numerator. It also can't be 1, positive 1. Because if x was positive 1, we notice that if x equals 1, we get division by 0. And we can't allow division by 0. That causes problems. So if we were going to indicate domain restrictions, we have to make sure we restrict it from x being negative 2, negative 1, or 1. Let's try one more. We notice that the coefficients of the terms don't necessarily have to be 1. If we try looking at, it also doesn't have to be an x. If we look at 4t squared minus 1 divided by t squared minus 5t, and then we divide that by 2t squared plus 5d plus 2, 2t squared plus 5t plus 2 divided by t squared minus 3t minus 10. We'll break this down. We're going to get 4t squared minus 1 divided by t squared minus 5t times the t squared minus 3t minus 10, all divided by 2t squared plus 5t plus 2. Now we can do our factorization. We notice we're going to factor the 4t squared minus 1 as 2t minus 1 times 2t plus 1, all divided by t times t minus 5. Then there'll be times, that'll be times t minus 5 t plus 2. And we notice that even if we don't know the factorization of t squared minus 3t minus 10 is t minus 5t plus 2 right away, that factor of t minus 5 lets us know to at least think about it. We notice if it was t minus 5, we would have to multiply negative 5 by positive 2 to get negative 10. And then we notice we get the negative 5t plus 2t is negative 3t, and so that factorization worked. Then we're going to divide by, we notice we're not sure what the factorization of 2t squared plus 5t plus 2 is. We could use AC method, but again, we notice that if we've got that 2t plus 1, we could make an educated guess that the other factor would have to be t plus 2, so we get 2t squared and positive 2, and then we notice that if we multiplied it out, we would get 4t plus t is 5t. And then we notice that the 2t plus 1s go away, the t minus 5s go away, and in fact, we notice the t plus 2s go away. That'll happen sometimes. We'll occasionally notice that we'll have factor simplification within one of the terms. And so we notice that we're going to get 2t minus 1 divided by t, as long as t isn't, what do we have to restrict? Negative 1/2, positive 5, negative 2, and I think we also have to restrict anything else. That does it. That takes care of everything. So we just have to restrict t can't be negative 1/2, positive 5, or negative 2.